Hey Gennady, you wanted me to go over a couple of these problems, so let's take a look. For the first one, it says, which of the following statements is not true for all real numbers A and B? This question is a question about identities. For example, for choice B, A minus B times A plus B, that's equal to A squared minus B squared. That's called difference of two squares, or dots. So that's an identity that you should have known if you went through an algebra class. Another identity that you should recognize is C, which is called the expansion of a cubic. If you took this and multiplied it all out, it would give you a to the third plus 3ab, a squared b plus 3ab squared plus b cubed. So what you could do, if you had no idea about any of these identities, is multiply them all out. And letter D, choice D, is the one that actually doesn't give it to you. I know that a times a squared gives you a to the third. I know that b squared times b gives you negative b to the third, right? But you have to also do a times negative b, which gives you negative ab. And you also have to do b squared times a squared, which gives you a squared b squared. So students, I guess, don't remember that. So that's the first question. It's talking about, which one is not an identity, and choice D is your answer. It's not an identity. The second question, question number 5, it talks about positive integers, and it gives a definition. It just says whatever letter or whatever number A is and whatever number B is, you put it in for A here and you put it in for B here. So it says, what is the value of 2 and then x2 and then x3? So the first thing we're going to do is do 2x2. This is our A value and this is our B value. So what we can do is write out, parentheses 2. And then the value of A is going to be 2. So we're multiplying that by 2. And then we have a minus there, and then a 1 there. And we close parentheses. And the exponent is B minus 1. You can see that the B value is 2. So the exponent is 2 minus 1. So to the power of 2 minus 1. So we can start simplifying this. 2 times 2 is equal to 4. Minus 1. Well, 4 minus 1 is 3. And notice that the exponent is 1. So anything with the exponent 1, we don't have to worry about. So 4 minus 1 gives us 3. So now that's the first part here. Now we know that the whole first value, which is A, is 3. Now we're going to have to do that same thing, but the whole first value, which is A, is 3, and the second value is 3 as well. So we'll rewrite it. It says parentheses 2 times A. We just found that A was equal to 3 minus 1, close parentheses, and then the exponent on the outside is 3 minus 1 this time. So 3 minus 1 is equal to, well, let's do it out here. We get 2 times 3, which is 6, minus 1 inside the parentheses, and on the outside parentheses is 3 minus 1, which is 2. So 6 minus 1 on the inside of parentheses gives us 5. The exponent is 2. So we know what 5 squared is. 5 squared is simply 25. So the answer for that should be 25. The next question that you asked about is question 17. They give you a graph. They give you a chart, which is actually pretty generous. Usually you either get one or the other. And the scientist estimates the number of bacteria in a sample every hour. And it looks like it's going upwards, right? It's increasing. This is a type of function called an exponential function. So what you have to do is find one of these 4 choices that is modeled by an exponential function. And you can actually answer this without even getting into any heavy math, just by looking at them. Choice D is a logarithmic graph. A logarithmic graph, it goes a little something like this. The logarithmic graph sort of starts underneath here, and it sort of comes up, but then tails off like this. So logarithmic graphs, also square root graphs sort of look like that. Well, that doesn't look like that at all. It's curved the wrong way, so that can't be it. Choice C, you can recognize that square, that's a quadratic, so it would go down and then come up, or vice versa, go up and then come down. So that doesn't look like that. This is exclusively going upwards, so that's not it either. The third one, or letter B rather, is a linear graph. It's got one number for its slope and one number for its y-intercept. So you would start at 100 and you go up by 2 every time. It should be a straight graph. That's not straight, it's curved. Well, luckily, we found our answer. It's the first one. It's an exponential starting at 100. That's the starting value. And 2 to the t power means it doubles in size every time. And it doesn't look like it exactly doubles in size every time, but it's pretty close. So, not so bad. All right, for question 33, I have to say it's a remarkably good picture quality. Thank you for that, Gennady. In question number 33, it gives you a weird, crazy graph that hits the origin. And it says this is the graph of y equals f of x. It's asking which of the following could be the graph of f of x plus 1. So this is a very small change to a graph. It doesn't change the size of the graph. It doesn't change like the type of graph, whether it's curved up or down. It just changes where it starts or where it intersects this origin here. So this x plus 1 refers to the fact that it is increasing its x value by 1 every time. The quick and easy way to do that is changes to the inside of the function on the inside of the parentheses. You do the inverse of them. So this is a plus 1. That means we're going to have to move the graph minus 1 in some way. Now, if it had said something like this, if it had said f of x equals, instead of x minus 1, notice how that changes on the outside of the parentheses. Changes on the outside of the parentheses here means going up and down. So f of x minus 1 would be this one right here, choice C, like that. If it was x plus 1, this represents a change to the outside, but it's going upwards. So that's going to be for choice D. But it's neither of those because it's the x plus 1 on the inside of the parentheses. So on the inside of parentheses, this should go with not going positive by 1, but by negative by 1. So this actually matches up with this one. Plus, in the inside, whatever is inside, you do the inverse, and that means it's a horizontal change. So I'll just write out the other changes for you. Okay, so I wrote out the other changes for you, and I know this might not seem like the easiest thing in the world, but it's just something you have to remember. A plus on the inside means you're moving to the left. A minus on the inside means you're moving to the right. A minus on the outside means you're moving down, and a plus on the outside means you're moving up. Okay. I wasn't sure which question to do over here, so I guess I'll do all of them. Question 35. If x and y are non-zero integers, the Regents love to do this. Like, oh, here are two numbers, but they're actually variables. Which of the following must be an integer? In other words, there has to be no possible way that this is going to give you like a decimal or a fraction or something like that. And if you take a look at the choices, they all have fractions in them, but only one of the fractions can be simplified. For this one, it might work to not give you a decimal unless the value of y is smaller than the value of x. Like if this was a 2 and this was a 3, it's definitely going to give you a fraction. So that's not going to be it. In this one, it could be that it's not a fraction. You know, it could be something that works. But, you know, you could plug in numbers to say, well, this could give you a fraction. For letter C, that's your answer. And the reason why it's your answer is because you can simplify it into something that's not a fraction. Notice that the x squared and the x have a common term. We can take an x out of there. And the x, y, and the x have a common term. We can take the x out of there. This is actually going to be simplified to x plus y. And it's the only expression in the whole bunch that can be simplified to something that's not a fraction, right? X squared divided by x gives you x. Xy divided by x gives you y. So that's the answer. If it must be an integer, then it can't be a fraction. That's what it's saying. All right, I'm guessing that question number 36 was the one that you actually wanted help with, but keep in mind that question 36, I've never seen it on like an algebra test. I've never seen it on a geometry test. I've never really even seen it on tests that weren't in like my college like number theory classes. But I mean, if you want to know how to do it, we'll talk about it. So this is talking about a Cartesian product. That means that the first set, which is A, are all the x values that you could possibly use. And the second set, B, are all the y values that you could possibly use. So what we have to do is we have to write out all of the different possible ordered pairs that you could get by using these guys as your x's and these guys as your y's. So let's first start with all the possible combinations using A as our x value. So I'm using A as the x value, and the y value could either be B or C. So I'm going to write A comma B. That's one possibility. And A comma C is another possibility, using A for x and these guys for y. Well, I didn't use B for x yet, so I could use B comma B, and it's okay that we use both letters, right? Because there's a B in this set, the set A, and there's a B in this set B. And the last one has to be still using B, but using C as well. So now that we have all the possible answers, we can check. Well, AB is there. BA looks like the one that's not there. And we can check the rest of them. B comma B, yep, it's there. And B comma C, yep, it's there. So I guess it's good that I remember my Cartesian products, and I guess it's good that you asked me this question. The last one, each number in data set A is increased by adding 3 to each data point to form data set B. So, you're just increasing every single number in the set by 3. Which of the following is the same for sets A and B? Well, you have to think of a number that, if you increase every single number in the data set, won't change. The mean represents like the middle of the values. So if every value goes up by 3, the mean's going to have to change. So it's not the mean. The median, same idea. It's the middle of the set, right? So if every single number in the set changes, that means the median has to change as well. So those don't work. The mode. Well, the mode is the one that happens the most. So like, if you have a data set that's 1, 2, 3, 4, 4, 4, 4, 4, 4, 4, 4, 4, 5, 4 is your mode. Well, if everything is increasing by 3, you better bet the mode increases as well, so that's not it. By process of elimination, it's got to be range, but here's why. So let's say you have a data set, and the data set is like, 1, 2, 3, 4, 5. And the range here, range is just biggest minus smallest, so 5 minus 1 is equal to 4. That's our range. Right? But as you can imagine, if we took all of these numbers and increased them by 3, so I guess that would be 4, 5, 6, 7, and 8, you're finding the range with the same calculation. You're just doing biggest minus smallest. So it would be 8 minus 4, and even though you increased every number by 3, the difference between the biggest and the smallest did not change, so the range stays the same. The range is a measure of spread in data, and it's not a measure of central tendency. So measures of spread are not affected by constant changes to the data set. That's a fancy way of saying I just mathed you.